It's with pleasure that I have Dr. Andrew Pelling here today with us from the Pelling Lab.
Yep.
And he's going to tell us a little bit more about augmented biology,
Sure.
which is a really interesting concept. And you also happen to be a professor at the University of Ottawa as
That's
well.
right.
Yeah. So first of all, we love that your organization, you and your organization, are advocating for this sort of marriage of art and science.
Yeah.
And taking a multidisciplinary approach to what you're doing in the lab. Can you tell us a little bit more about how that works in reality? The good and the bad.
Yeah, well, I mean, I've always been this believer that if we're going to ask really great questions, we really need to build a team that's just super diverse. And if you have a lab or a team that's just all engineers or all scientists, they're all kind of think in very similar ways.
Right.
But if you pepper in a bunch of artists and social scientists and people coming from different degrees and backgrounds and training, that sort of diversity of perspectives leads to some pretty unusual conversations, especially over a beer or two. And,
Absolutely.
You get great ideas this way.
That's great, and what an innovative way of bringing different disciplines together, because you do get different perspectives, and you can innovate when you do get, especially a little bit of dissension too.
Absolutely, absolutely.
So
yeah,
a
have
little bit
those
of conflict.
debates.
Yeah,
Yep,
that's
it's a good
great.
thing. I think more often than not, I'm actually a little bit bored, and so by mixing it up, you tend to just have a bit more fun, and it gets exciting.
Fabulous. So at Macadamian, our skills represent what you're doing in the lab in a similar way. So we have research, we have design, and then of course we have development.
Okay. Yeah.
And the purpose is for us to work with our clients to develop software that meets a need. So how do you see software as playing a role in healthcare today and going forward?
I've always kind of thought about software as that kind of glue that sticks everything together, because especially with the way sensors and hardware is developing now, all of that data is being streamed out to the internet or wherever. You need software to capture it, to categorize it, standardize it, and then you layer on top, machine learning algorithms and AI, and which are really there for teasing out insights and perhaps even diagnosing and acting on that information. That's all software driven, and you need that kind of glue to put everything together. It's critical.
Okay, so that leads to the next question, which was, we hear a lot about AI, machine learning, big data. Those are all hot topics right now. How do you see this affecting, or benefiting the healthcare industry?
They're very hot terms. I don't think most people really know what they even are.
Okay.
And it's hard to even define them sometimes. I think initially, well, even now, we're producing mountains of data that we just don't know what to do with.
Right.
And so there are some sort of shorter term challenges that need to be solved about how you integrate all of that information and standardize it, not even just across a city or a hospital, but how do we standardize it across the globe so that your data is everywhere, and you get hurt in France or Australia, that data follows you. How do we do that? And how do we make it safe and all of these types of concerns, address all of these types of concerns.
Right.
Once that's done, I think it's going to have a remarkable effect on healthcare as we sort of understand it, and probably really change healthcare from something where, for me at least, I would like to think that we go from personalized medicine, where prescriptions and treatments are based on your biometric data, to personal medicine, where we think about maybe healthcare becomes something like similar to the way we choose our clothes in the morning and choose what to eat, or I chose to go for a run this morning. Maybe in the future, with all of this data and integration and AI firmly integrated into our lives, healthcare decisions are made more on a personal, on-the-fly basis. I'm choosing today to address something I've been alerted to. I got a text message about something in my body I need to address, so I'm going to do that. Or I'm going to make a proactive cosmetic choice about my body and apply some sort of healthcare or preventative treatment. in a way that we just can't do right now
Okay.
because healthcare is kind of centralized.
So are you starting to look at the impact of AI and machine learning in terms of the lab? So what's the impact of that on augmented biology? for
Yeah,
instance?
we're thinking about it. We haven't. I think we've got other things we want to develop. We need to develop first before we get there. And one example is we've spent a lot of time building body parts. So using materials from nature to repair the body. And one of the questions that's sort of floating around in our heads right now is, if somebody, I don't know, breaks a bone and they get an MRI and you can see a defect, can you use machine learning algorithms to design the implant that would go in there for us, rather than us manually doing it, or using more or less sophisticated means to do that. The other element here is not just repairing the body, but could we say change the body, enhance abilities, or change function by using implants and growing muscle in places muscle doesn't normally grow, or putting nerves in places they don't normally grow, and can you use some predictive modeling and strategies that you derive from AI to design those types of implants. It's, I want a certain function, you tell me what type of implant I need to put in there to make that happen.
So including connections perhaps from the brain to, so I'm thinking MS, for instance.
Absolutely,
Okay.
yeah. These types of things, there are a lot of problems and a lot of interesting possibilities that we're working on,
Okay.
that might make these types of things possible. Who knows?
Right. So tell us about some of the, so there's always the question, or I guess the connection between research and then the private sector,
Yeah,
right?
yeah,
And so
yeah.
so research and then reality.
Yeah,
So
yeah.
how does what you are doing in the lab actually, become a reality in healthcare for
Right.
me, for you? So what are some of the, can you talk to that first of all, and maybe some of the challenges around that, but what
Yeah.
are some of the things that you guys are doing in the lab that have real implications
Right.
for healthcare?
Yeah, so it's funny, in the last few years, we've actually started to do things that have real world applications. We never actually tried to do that.
Okay.
I used to say, and I still do, I guess, that my lab, we're really good at working on pointless problems.
Okay.
Just like questions nobody would ever ask, they seem totally meaningless
Right.
and super fundamental and esoteric types of research questions. I was always very proud of working on problems like that. What started happening though, my lab's only 9 years old now. Over the last 9 years, we started the lab with this intention: we're not going to work on anything useful on purpose.
So not driven by big pharma.
No, not driven by pharma or money or applications. I don't care. I'm just here to create knowledge.
Awesome.
Very idealistic.
Okay.
But what happened was we started asking questions no one else was asking, and that led to discoveries. And those discoveries in turn led to applications. Not all of them, but certainly some of them here and there. And that's what I think we're really good at doing as human beings, is being curious. And we tend to lose that as adults, and as these pressures for meeting your market demands and all of that sort of take place. But in my lab, we've been able to harness curiosity as a driver for innovation and discovery.
Okay.
And the best example is most recently, in the 9 years, we've now spun out 3 companies.
Okay. Wow, that's fantastic.
Which is, for a lab that never intended
Yeah.
to do that, it was remarkable.
Yeah.
And that was driven by my team, these diverse teams. Some people were more entrepreneurial than others, and we had that mindset. Let's make this a company. Let's do this. The best example is Spiderwort, which is taking work. We were initially interested in knowing, could we grow human cells and tissues inside of apples?
Okay.
And what we were really trying to do was create the monster from Little Shop of Horrors, which is this plant that eats people.
Right.
And it's got muscle, and it's a plant, and it sings, and that was kind of cool. What we discovered in that process was that we could use plants as a material for repairing damaged tissues.
Okay.
And there's a very big market and need for this, whether your body is injured because of disease or some sort of accident.
So plant-based versus animal-based,
Yeah.
which is what we currently...
Yeah, exactly. That's the
Okay.
problem we're actually solving.
Okay.
Is current materials for this are derived either from like human cadavers, dead people,
Right.
Or animal products, or expensive polymers. So there's
Okay.
lots of costs and ethics, and even criminal cases that have arisen because of that. So we're solving that problem with plants, which are everywhere.
Yes.
And that's gone now. It's going now into clinical trials and into the commercial space, and it's formalized through a company, a startup, and become a real thing. And we should be into human beings very soon. So that's directly impacting people's lives,
Wow.
kind of by accident.
Okay.
So
That's amazing.
yeah.
So just as my last question, I don't want to keep you too long, but what kind of advice do you have for other people out there, especially young people who might be graduating with
Right.
a degree in biology or chemistry,
Right.
and they're really excited about improving people's lives? What
Yeah.
kind of advice do you have for them?
I think, so I get this question a lot.
Okay.
I don't know if I have a very satisfactory answer, but the one thing I'm seeing a lot of in young people, especially because I'm a professor, I see a lot of undergraduates. I keep seeing this intense fear of taking a risk, of being different from the crowd, of doing something that's kind of unusual or doesn't follow a formula to get me a job.
Okay.
And we're seeing so many graduates now all across the world. If you look like every other graduate, you don't distinguish yourself in any way. And the world doesn't need people to follow formulas.
Right.
The world and what companies need right now are people who know how to think differently, but also not just come up with crazy ideas, but know how to execute on them.
Okay.
And I would spend time building things, building companies, building prototypes, building social initiatives, whatever.
Okay.
But build something. And that's, I think, the thing that will ultimately make you stand out from a pile of CVs that all look the same.
Okay. And as part of that, I'm assuming be prepared to fail and don't be afraid to fail.
Yeah,
if
so
you're trying
yeah,
things over
yeah.
and over again.
Taking risks. This is why it's a risk, and most likely you will fail. And we should stop seeing that as a negative thing. That's how
Right.
you learn, and it actually, my lab does this day to day. We work on crazy projects. Most of them fail. We learn a lot from that, and that feeds into the next project. And those failures have always been beneficial to us. And even in my life, it's the same thing. So.
Well, you are an excellent example. So thank you so much
No
for
problem.
taking the time. It
Yeah.
was a pleasure speaking to you.
Thank you.
Thank you.